Hello student, this is Digital Knowledge Irshad Academy. In previous video, I told you that we'll solve three numericals. In first, we'll find out how a small signal is amplified to a large value, and then in the second case, we'll find out the gain of operational amplifier. In the third, we'll find out the percentage of variations in voltage output. Before going to explanation, subscribe my channel and press bell icon so that the next video reaches you. Looking down the circuit configuration, we have a black box. These are the values or the specifications given. We start from this side. Vs is a source voltage or supply voltage is 1 millivolt. Zs is 0. Zi input impedance is 1 kilo ohms. This is the output control generator. The gain is 1000. Zo is 50 ohms. Zl is 1 kilo ohm. And we have to find out what is V0 or output voltage. The first is, we'll find out, we know V1 is equal to Zi over Zi plus Zs into Vs. V0 is equal to AV1 divided by Zo plus Zs, Zo plus Zl into Zl. Zi in this example is 1 kilo ohm. We will write here 1000 ohms, and in the denominator we will write 1000 plus 0 into 1 millivolt, and here we will write V0 is equal to, gain is 1000. We have to first find out V1. We just come to V1. This is 1000. 1000 plus 0 is 1000 multiplied by 1 millivolt. This 1000 cancels with this. V1 is equal to 1 millivolt, and we can here write Zo is 50 ohms plus Zl is 1000 ohm. V1 is 1 millivolt multiplied by 1000. This we can write 1000 over 1050 multiplied by 1 into 10 raised power minus 3. 1 millivolt is equal to this multiplied by 1000. Now this 1000 cancels with this. This 0 cancels with this 0. We are left with 100 over 105, or 5 stable. 520 times 100. 5 2 times 10. 5 1 times 5. This is 20 over 21. This is nothing but 0.95 volt. This side we are giving 1 millivolt, and in the output we get V input is 1 millivolt. 1 millivolt means when you divide 1 volt by 1000 times, you break into 1000 part and you pick up one part will be called as 1000 part of 1 volt, or we will call 1 millivolt. That is 1000 part of voltage has been amplified to almost 1 volt. Why? Because this is almost 1 volt. Since the gain is 1000, this input voltage of 1 millivolt has been amplified to 1 volt. See that very small voltage of in the order of millivolt has been amplified to almost 1 volt. In the second example, is these are the specifications given. Vs is 3.5 volt. Vs source voltage or supply voltage is 3.5 millivolt. Zs is 250 ohms. Zl is 600 ohms. Zi is 15 kilo ohms. Zo is 150 ohms. V naught is 10 volt, and we have to find out gain of the amplifier. Why? Because the output voltage is given. We start by the formulas. We know V input or V1 is equal to Zi over Zi plus Zs into Vs, and here V naught is equal to A Vi over Zo plus Zl into Zl. Let us now put the values. Zi is 15,000 ohms or 15 kilo ohms divided by 15,000. That is 15,000 plus Zs is 250 ohms, and Vs is equal to 3.5. We can write 3.5 multiplied by 10 to the raised power minus 3. Alright, this can be written as 15,000 divided by 15,250. When you add these two, it becomes this, and multiply by 3.5 into 10 raised power minus 3. This 10 minus cancels with these 3, and this is, we read the 5 time table. 5 2 times 10, 5 7 times 35, and we now have again table of 5, 3 times 15, 5 3 times 15, 0, 5 times 25, and 0. This we write 3 divided by 3050 multiplied by 7.7 by 2, and this is equal to 21. 7 is multiplied with 3 and 2 multiplies, and this comes 6 100, nothing but 0.003 volt. This is V1. Now we go here, A, we have to find out A, we do not know what is A. V1 is 21 by 6100, 21 by 6100, ZL is 600, ZL plus ZO is 600 plus 150 is 750. And we can write these V naught was given as a 10 volt. Now by transposing we will multiply this with this, it will become as 10 multiplied by 750 multiplied by 6100 is equal to A into 21 into 600, or we can take out the A, we can write A is equal to 10, 750, 6100 divided by 21, 600. These two zeros cancel with this, and this becomes we read the table of 3 7 times 21, 3 2 times 6, 3 5 times 15, 3 0 0. Now we have 10 250 multiplied by 61 divided by 42, or we can write 2500 multiplied by 61 divided by 42. This is nothing. If you divide it, we get 3631, and this is nothing but our A. A now is equal to 3600. We have calculated the gain of this amplifier. If we use an op-amp of 3600 with gain of 3600, it is going to amplify 3.5 millivolt to 10 volt in the output. All specifications were given, but A was not given. We were to find out A. We found out A in that we find that A is 3600. If we can buy an amplifier whose gain is 3600, then with this specification it is going to amplify 3.5 millivolt into 10 volt. Now coming to the third numerical. This is the third example. black box. Third example, Zi input impedance is 10 kilo ohm, A is given 1000, ZO is 50 ohms, then increase to 500 ohms. Vs is 1 millivolt, ZL is 1 kilo ohm, Zs is 50 ohms. We have to find out V naught when the output impedance ZO is 50, and we'll find out the output with when it is increased 10 times to 500. The effect of increase in ZO at the output voltage. First, as usual, we'll write the formula is equal to Zi over Zi plus Zs into Vs. V naught is equal to output control generator divided by ZO plus ZL into ZL. Let us put the values of here. E1 equals Zi is equal to 10 kilo ohms, and in the denominator we have 10,000 plus Zs is 50 ohms. Multiplied by Vs is 1 millivolt, 1 millivolt. This can be further written as 50 ohms in parallel with 10,000 ohms is a small value, can be neglected, and this becomes 10,000 divided by 10,000, 50 ohms is neglected, into 1 millivolt. This 10,000 cancels with this. V1 is equal to 1 millivolt. Why? Because Zs is very small, 50 ohms is going to drop very less voltage, almost 1 millivolt in the output appears across Zi, so Zi is 1 millivolt. Let us now write the output formula. A is 1000, gain is 1000, ZO for the first time is 50. We write ZL 1000 plus ZO 50 into ZL. Vi is 1 millivolt, ZL is 1000. This can be written as 1000 divided by 1050, because 1000 plus 50 is 1050, but in this case it was 10,000 plus 50, and this 50 can be neglected. This 1 millivolt cancels with this, so this 0 cancels with this 0. We have 100 over 105, 5 stable, 5 2 times 10, 5 2 times 10, 5 1 times 1, and we have 20 by 21, this is nothing but 0.5 volt. This is V0 when ZO was 50 ohms. Now the second case, this is the first case. Now let us find out in the second case. V0 is equal to AV1 divided by ZO plus ZL into ZL. Let us write the values. A is 1000, V1 is 1 millivolt, 1 millivolt, 1 into 10 to the power minus 3 divided by multiplied by 1000 ZL. This ZL 1000 cancels with this. We have then 1000 divided by 1500, and these two cancel zeros. 5 tables are 5, 3 times 15, 5 2 times 10 is equal to 2 by 3, and this is nothing but 0.66 volt, 0.66 volt. In the first case, V0 was 0.9 volt calculated. In the second case, this was with the 50 ohms. This was with the 500 ohms. In the second case, when the ZO was increased to 500, the output voltage dropped to 0.66 volt, and the voltage which dropped from 0.95 volt to 0.6 volt, the difference is 0.9 volt. And we further can find out the variation in percentage. 0.29 was the difference, and it brought the output to 0.66 volt. For 1, it is 0.29 divided by 0.66. For 100, in order to find out in percentage, it is multiplied by 100. And this decimal cancels with this, so we are left with the 2900 multiplied by 66, and if you read the table, this is 44 times, and of course in percentage. Finally, we conclude that with the same input voltage, with 50 ohms, we got 0.95 volt. But when the ZO was increased 10 times, here from 50 ohms to 500 ohms, the output voltage had fallen from 0.95 volt to 0.66 volt. And in percentage, we see that 0.29 was the difference between the two voltages, and it brought the output voltage to 0.66 volt. For one it is 0.29 divided by 0.66 multiplied by 100. This decimal cancels with this decimal. It is 2900 by 66. And the percentage variation is 44%. We conclude that when the output impedance was increased from 50 to 500s, the output voltage reduced from 0.95 volt to 0.66 volt. That means the output voltage decreased by 44%. And that's all. In the next video we will learn practical op amp. Thank you very much.